College Algebra, Chapter 3, Section 3 is about dividing polynomials, the remainder, and factor theorems. And this is slightly tedious stuff. It's not impossible, but it can be a little irritating. For example, I find reading this entire blue box right here to be irritating. It's like step-by-step instructions for the long division of polynomials. I intend to simply show you an example, and we'll talk about it as we go along. So we're going to divide the first polynomial, which has 4 terms, by the second polynomial, which has 2 terms, which makes it a binomial. And we're going to accomplish that using long division. We will state the quotient and the remainder. Great. Let me first take you for a little stroll down memory lane. I'm going to divide the number 3 into... let's do 642. How many times does 3 go into 6? 2 times, and notice that I wrote the 2 above the 6, and then we take the 2 and we multiply it by the 3 and we get 6, and then we do subtraction. Normally we would just put a minus sign there. I'm going to put my minus sign in parentheses. And in this case we get 0. And then we bring down the next number, which is a 4, and we repeat the process, asking ourselves how many times does 3 go into 4? The answer is 1. We take the 1, we multiply it by the divisor, 3, we get 3. We set up for subtraction, we put a minus sign. I'm putting my minus sign in parentheses. We subtract, we get 1. We bring down the next digit, and we repeat the process. Notice that there's a process here that we keep repeating. How many times does 3 go into 12? Or 3 times what equals 12? We could ask it that way, which is convenient in this case because it's 4, and 3 times 4 actually gives us 12, and when we do our subtraction this time we get 0, and since there are no more digits to bring down, that 0 is our remainder. Perfect. So often, usually we wouldn't put anything. We could put a little lowercase r with a 0 right here, but since there's no remainder, I would say typically we wouldn't do that. So now let's change the problem just a little bit. I'm going to take this 2 in here and I'm going to make it 643. And since that's a 3, I had to bring down a 3. And then I do the subtraction, and instead of getting 0, I get 1. And what's that? Well, it's still the remainder. And we could take that leftover 1 and we could put a little r with a 1 after it, saying that it's our remainder. What if you had to share 7 cupcakes between 3 people? 3 people are going to share 7 cupcakes. Well, 3 times what equals 7? Not a really nice number. 3 times what number would get us close to 7? How about 2? 3 times 2 gives us 6. Okay, that's close to 7, just a little bit short. That's good. 2 times 3 is 6, and we can do the subtraction and get 1. And you can imagine it passing out these cupcakes to the 3 of us. 1 for you, 1 for you, 1 for me, 1 for you, 1 for you, 1 for me, and then there's this extra cupcake left over. What are we going to do with that? Everybody really likes these cupcakes, so we're going to have to split it into thirds. So how much additional cupcake does each person get? And the answer is an additional 1/3 of a cupcake, because I'm going to take that 1 cupcake and I'm going to cut it into 3 pieces. In other words, I took the remainder. Did that move? Oh, that's not good. Well, let's make it legible.
as I was saying, in other words, I took the one extra cupcake and I still cut it into 3 pieces. So that's why the answer to this would be 2 1/3 instead of 2 remainder 1. What are we going to do? Throw away the extra cupcake? Let's be real. We're splitting it evenly. The reason why I wanted to go through those two sort of old school second or third, or maybe third grade processes is because it's analogous to what we're going to do in our polynomial long division. So let's get into this. We're going to set it up the same way. The x minus 3 is the divisor, and it's going to divide into x to the third minus 2x squared minus 5x plus 6. And you heard me ask this question in an unusual way when we were looking at the these numerical problems that we just did. Especially when I was looking at this one, I said at the very beginning, I could ask how many times does 3 go into 7, but instead I said, what number times 3 would get me close to 7? And I came up with 2, because 2 times 3 is 6, which is pretty close to 7. It's a little bit less than, 6 is less than 7, but it got me close. I'm going to ask that same type of a question here as we start this polynomial division process. Instead of asking you, how many times does x go into x to the third, instead of asking you that, I'm going to ask you, x times what equals x to the third? And I think you'll agree that the answer to that question is x squared. Now, where am I going to write the x squared? I'm going to put it in the appropriate column, just like there's a ones column, a tens column, a hundreds column, a thousands column. Here, we have a constant column, and a linear column, a quadratic column, and then we could just say a third degree column because the exponent is 3. And again, I'll ask the question, how many, or x times what equals x to the third? The answer is x squared. So where am I going to write x squared? I'm going to put it in the x squared column up here. That's the first step in the repetitive process. Now we're going to do it like we did in 3rd grade, or whenever it was. If my eraser works, there we go. I'm going to take the x squared and I'm going to multiply it by the x. Taking the x squared, multiplying it by the x, and I get x to the third. Notice that I wrote that under the other x to the third stuff. Now this is a little unusual compared to what we did in 3rd grade. I'm now going to take the x squared and I'm also going to multiply it by the negative 3. We have to take that x squared and multiply it by the entire divisor. So I'm putting the x to the third back, and then x squared times negative 3 makes negative 3x squared. Okay, I took that, multiplied it by the whole divisor. Now we're going to do subtraction, just like we did back in the day. I'm going to put my minus sign here, but I'm going to put it in parentheses, and we'll do subtraction. X to the third minus x to the third is 0. It should work out that way every time. That first little bit of subtraction that I just did there should equal 0. If it doesn't, then you chose the wrong number up here, or you did the wrong multiplication when you multiplied it by this thing, the first term in the divisor. So again, these should cancel out, and they do. And then I ask myself, what's negative 2x squared minus negative 3x squared? It's a double negative. Don't go putting plus signs, changing your minus signs to plus signs. Don't take that negative and actually change the sign on all the terms. It makes it impossible for you to check your own work in case you made a mistake. Leave it as it is. Think of it as a double negative, because that's what it is. So now it's negative 2 minus minus 3. If you have to go into the margin and write negative 2 plus 3 and then do that arithmetic, that's fine.
but don't modify what these things say in here. Leave them as they are. Trust me, I do this for a living. So we get positive x squared, and then there's that last step that we did in third grade where we bring down the next term. And if you want to extend your line through here, you can. It's up to you, but I'm bringing down a negative 5x. And then we're going to repeat that process. X times what equals x squared? And the answer is x. Where am I going to put that positive x value? I'm going to put it in the x to the first power column. Positive x over all of the other x's, right? They're all still lined up, good. And then we carry on with that repetitive process. So we said that x times what equals x squared, and the answer was x. So now we're going to take this x and we're going to multiply it by the x, and then we'll multiply it by the negative 3. X times x makes x squared. X times negative 3 makes negative 3x. Set up for subtraction. Begin subtraction. X squared minus x squared cancels out. Perfect. That's telling me that I'm doing this correctly. So I'm happy to take the time to realize that. And then next we've got negative 5x's minus negative 3x's. It's as though it's addition. So we've got negative 5 plus 3, which gives us negative 2x. Bring down the plus 6 as our next term instead of our next digit. And we repeat the process one more time. X in the divisor position. X times what equals negative 2x? The answer is negative 2. So I put my minus 2 up here in the constant column. No variables there, so they're constants. And then we take that negative 2 and we multiply it by our entire divisor. Both terms in the divisor, so negative 2 times x makes negative 2x. And negative 2 times negative 3 makes positive 6. Set up for subtraction. Minus sign in parentheses. Here's a good illustration of why putting the minus sign in parentheses is a good idea, because it's literally a minus sign next to a minus sign. You don't want them to blur together depending on how sharp your pencil is, or if you're doing your homework in crayon or blood or tears or whatever it is that you're writing with. So keep using parentheses around that minus sign. And we do the subtraction and it turns out we get 0. A remainder of 0 in our first long division problem here. What does that mean? Well, I don't know about you, but when I was a kid, if we took 3 and we divided it into 6 and we got 2, and we got a remainder of 0, we would say that means that 3 divides into 6 evenly. Maybe you said it the same way. Here in blue, what I'm seeing is that x minus 3 divides into x to the third minus 2x squared minus 5x plus 6. It goes in evenly. All right, I'm really going to blow your mind now. Check this out. It's so mind-boggling. I can hardly even articulate it. In this problem, 3 is the divisor. 6 is actually called the dividend. That's how it's spelled, dividend. And 2 is the result of doing the division, so that's called the quotient. If you take the quotient and you multiply it by the divisor, you should get the I think it's spelled just how it sounds, dividend. Maybe it's dividend, but I think it's and. Quotient times divisor equals dividend. 2 times 3, there it is, 2, if my pen will work, 2 times 3 equals 6. Told you, it's mind-blowing, right? Now, this only works, well, it's very clear that this works when the division happened evenly, when there was a remainder of 0. But you can apply this same thing that I wrote in green, quotient times divisor equals dividend, to the problem that we just did in blue. this quotient times this dividend, or divisor rather, does equal this dividend. You can multiply those together and FOIL and combine like terms and whatever, and you'll get the x to the third minus 2x squared, blah, blah, blah. You can hardly stand it, right? It's amazing. You're on the floor right now. Very clear that that works when the remainder is 0. Is it going to work that way when the remainder is not 0? Yes. You'll have a remainder like a third of a donut hanging around, and you would still have to take that third of a donut as part of the quotient and multiply it by the divisor, which, as it turns out, is going to go very nicely, and it will still equal the dividend. All right, polynomial long division, yeah, here it is. You can multiply it out. Here's the divisor times the quotient, and then you could just add the remainder, or I could show it to you another way, and you'll get the, oh, there it is, D-I-V-I-D-E-N-D, dividend. If there's a remainder of 0, oh, even the pros tell us it divides evenly. Okay. Well, let me ask you one other question. Here it is. Quotient times divisor equals dividend. When you have two things like this that are connected by multiplication, what are those two things called? Are they called terms or are they called factors? The answer is they're called factors. When things are separated by addition or subtraction, they're called terms. But when they're connected by multiplication, or theoretically division, I suppose, because division is multiplication, but that's a conversation for another day. When they're connected by multiplication, those two things are called factors. Which means that since it divided in evenly, check out the screen, look at the green, Q and divisor are factors of the dividend. I can change this now. It's dividend. There we go. Great. Let me say that one more time. In this case, where it divided in evenly, the quotient and the divisor are factors of the dividend, because I can write the dividend as a product of the quotient and the divisor. A product, multiplication. I'm really belaboring that. Maybe that's something that I should be keeping in my mind. There's another way that you can do polynomial division. You can't always do it this way. If the thing that you're dividing by, if the divisor is a first degree polynomial, if it only has the largest exponent of 1, then you can use synthetic division. Again, it's even said here, we can use synthetic division to divide polynomials if the divisor is of the form x minus c. So it has to be linear. And this illustration helps us set up the synthetic division process. If I take this divisor of x minus 3 and I set it equal to 0, and then I solve for x, I get x equals 3. If I took that 3 and I plugged it in here for x, 3 minus 3 would be 0. Therefore, 3 is the 0 of the divisor. Because if you plug it in, it makes the divisor equal to 0. Okay, so 3 is the 0 of the divisor. And they've written it for us here. And you're seeing this number 3, well, I'll just cut across here. It's appearing in this little box. Super. Now, the dividend is 1x to the third plus 4x squared, see the 4 there? Look over to the right, see the 4 here? Minus 5x, now look to the right, minus 5x plus 5, see the 5, see the 5, okay? See how those are matching up? So we took the coefficients from the dividend and brought them over and put them in a row next to the 0 of the divisor. I'm trying to be as articulate and deliberate about this process as I can. Not only were those things brought over there, these 5 items, the last part of the setup process for synthetic division says take whatever number this is and bring it down here and write it under a line. So I guess the line is also part of the setup process. So we've got those 5 numbers on top. We took the first number and brought it down below the line. And we have to make sure that we save some space in here because obviously we're going to be writing some other numbers there. Notice also that this long division process here had a remainder, and that remainder is showing up as our last number in the synthetic division process. You're welcome to look at this. I'll pull this down here so you can check it out. If you want to read through this articulation of this long division problem, I think that's a great idea. Exposing yourself to as many different ways of phrasing the process is a great idea. Here you can see those 5 numbers appearing and they're bringing the 1 down. And then after that, there's this repetitive process that starts just like we saw with long division that I did in that previous problem. What they've done is they took the number from the box, the 0 over the divisor, the 3, they multiplied it by this 1 right here. 3 times 1 is equal to 3, so this 3 then gets written here. Once that 3 is there, we move down to the next step, and what happens in here is we're going vertical. We're adding the 4 and the 3, which gives us the 7, which is the next number below the line. And then we repeat the process. Now, down here, the 3 is multiplying by the 7 to give us 21, which is appearing here. And then we go vertical again and add negative 5 plus 21 makes 16. And then we repeat the process. Down here, 3 times the 16 this time gives us 48. And we go vertical. We add 5 and 48 makes 53. Once we've got that 53, we've run out of numbers to work with, so we're going to stop there. And 53 is going to be interpreted as our remainder. What are we supposed to do with these numbers? Well, let me back up. Let's go back to the original problem here. So come with me back to here. We're taking this expression, the dividend, x to the third plus blah, 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 and we're dividing it by x to the first minus blah, blah. In other words, we've got x to the third divided by x to the first. What is x to the third power divided by x to the first power? The answer is x to the second power. 3 above 1, we do the subtraction, the upper number minus the lower number. In terms of exponents, 3 minus 1 gives us 2. That's how I remember that when I'm interpreting these numbers right here, this first number tells me how many, in this case, x squareds I have. So again, x to the third divided by x to the first meant x squared. How many x squareds? 1x squared. And there it is, 1x squared. From there, the exponents decrease. This 7 corresponds to 7. Positive 7 is how many x to the firsts we have. And the 16 corresponds to how many x to the zeros we have. In other words, 16 becomes our constant value. And then there's the 53. The 53 leftover cupcakes is a lot of cupcakes. but we're still going to divide them literally by the number of people we're sharing between, and that's the divisor. So here you see that 53 is not being cut into thirds, it's being divided by x minus 3. So the remainder still gets divided by the divisor. The number of leftover cupcakes still gets divided by the number of people sharing cupcakes. There's one difference. I think it is. I think it's the only difference really in our presentation of the remainder being divided by the divisor. The difference between this problem and when you were in third grade is right here. It's that plus sign. Between your last digit, or in this case your last number, the 16, and the remainder over the divisor, there should be a plus sign. Now what if my 53 had turned out to be negative? That's okay. Go up there by the 53, there it is, and put in a negative sign. You would add a negative numerator over a denominator. Couldn't I move this down to here and change my plus sign to a minus sign? You sure could, and that's acceptable. If you're typing this into an online platform, there may be a restriction on how the software will accept it. It might want you to put plus and then put a negative numerator. But you must put some sort of operator right here. Whether it's a plus or a minus, there's got to be something there. Otherwise, computer software thinks it's multiplication. It'll do 16 times that fraction, 53 over x minus 3. We don't want that to happen. We did a lot of work to get here. So you've got to have that plus sign. In third grade, notice we didn't do that. This just says 2 and a third. We put them right next to each other. Is it equivalent to 2 plus 1/3? Absolutely. They are 100% equivalent. We just didn't do it that way when it was just numbers. But now that we're working with these expressions, we're going to put a plus sign in there typically. All right, so that would be your answer to that division problem, with your remainder being added and divided by the divisor. Let's try this one. The divisor is x minus 3. The 0 of the divisor is an x value of 3. So again, 3 is the 0 of our divisor. We're doing synthetic division, so the 3 is going to go into this little box, partial box. The numbers that go next to it are the coefficients of the dividend. We have 1x to the 5, and then leave some space in here because we're going to write more things than we usually would. Positive 4x to the 4th, negative 3x squareds, positive 2x's, and positive 3 for a constant. Now if you're using lined paper, then you wrote those numbers on one line, and then you're going to skip a line, and then you're going to draw a line, and then we're going to take this number 1 and we're going to bring it down here as part of our setup process. All right, I'm not going to draw probably any more of those curves like I just did in green there, or this thing's going to start to look like a bowl of pasta. It's the best I could do for an analogy on short notice. Okay, so now let's begin this repetitive process. We take the number from the box, we multiply it by the number below the line. That's 3 times 1. That's equal to 3. And then we add, and we get 7. And then we repeat that process. The number from the box times the number below the line. Oh man. I was even thinking about it while I was doing this problem, and I didn't look closely enough. Right, shouldn't this be 171? That's our constant value, no remainder? No. If there were no remainder, that we would have a 0 here. But there's no 0 there. What happened? I'll tell you. This 1 right here represents how many x to the 5s I have. This 4 represents how many x to the 4s I have. How many x to the 3s do I have? Look at the original dividend. I don't have any. It skips from plus 4x to the 4 to minus 3x to the 2. That's a problem. We needed to account for that in the setting up of our synthetic division process. Even if we were doing a long division, we would have had to insert a placeholder. Long division or synthetic division, have to put in a placeholder. So, I'll show you what the erasing would look like. All right, take 2. So I just finished working this problem with an error where I did not include the placeholder, which we're going to insert right now. And the placeholder has to happen because in the original dividend, you'll notice that we don't have a term that has an x to the 3rd power. In other words, we have 0 x to the 3rds. And so, as I continue writing out these coefficients, I'm going to include a 0 x to the 3rd. And then we have minus 3x squareds and positive, I don't need the plus sign there, positive 2x to the 1sts, and 3 for a constant value. All right, so let's continue this repetitive process. We take the number from the box, that's the 3, multiply it by the 7, makes 21. We add vertically, little plus sign there, and we get 21. And then we do 3 times 21, and we get 63. And we add vertically, 60. Again, repeat, number from the box, times just sneaking in that little 3 times 21 there to the left of the 63. We added, we got 60. Now we repeat, we do the 3 times the 60. That's the number that's in the box times the number below the line. 3 times 60 equals 180. And we add, which gives us 182. And we multiply one more time. 3 times 182 equals, I'm not doing it, 180. 18 times 3 is 546. Not there. Up here. And then we have to add the 3 and the 546 and get 549. The 549 is going to be our remainder. So if you are in the habit of putting some kind of a little partial box there, that's fine. And then let's go through and make sense of these numbers. Remember that we started out, it's hiding behind me, just below me there, it says x to the 5. It's x to the 5th that's being divided by x to the 1st. So x to the 5 over x to the 1 makes x to the 4. That's how I know that this 1 right here represents 1 x to the 4th power. And the positive 7 tells me how many x to the 3rds I have. And the positive 21 tells me how many x squareds. And the positive 60 is how many x to the 1sts. And 182 is my constant value, or 182x to the 0. And notice the plus sign, notice the plus sign. I have to take my remaining cupcakes, all 549 of them, and divide them by the original divisor, which was, at the top of your screen, x minus 3. This is the quotient, the result of the division. There are lots of polynomial division problems out there available for you to practice. If you can find other sources of video where synthetic division problems are worked out, I recommend checking those out. And at the beginning of the process, once whatever the video is, if it's from your textbook provider or whatever, once you're started out with this initial problem here, once you're presented with that problem, pause it and then try to set it up on your own, and then push play and watch how they set it up, and then pause it and go through the first couple of steps of doing the division process, and then play the video and have it catch up so you can be checking your work against the video and go through like that, just every one stage at a time or a couple of steps at a time until you're so good at it that you can be making your own videos without messing up and forgetting to put in a placeholding term because you're missing a variable to an exponent. Don't do that. Okay, let's keep this train moving on to the remainder theorem. And the remainder theorem says that if a polynomial is divided by x minus c, then the remainder is f of c. What does that even mean, right? What it means is x minus c. What's my c value? Looks like it's 3 to me. If I take that value of 3 and I plug it in to this polynomial, and I do 3 to the 5th power plus 4 times 3 to the 4th power, let's do it. Let me prove it to you. 3 to the power of 5. Let's clear out that other stuff first. 3 to the power of 5 plus 4 times 3 to the power of 4 minus 3 times 3 to the power of 2 yep, plus 2 times 3 plus 3. My camera's not set to focus on this, so I'm going to mess everything up right now. Will it get that close? Nope, that's going the wrong direction. Get it together. Oof. It's too bright. This is not going as well as I wanted it to. Can I just grab this ND variable ND ring? Wrong way. Nope, that's not the right ring. Come on, where is it? Oh, there we go. Blurry. Impossible. The thing's so small that I can't even tell what it says. Anyway, that was a good try. Now look what I've done to my camera. It's 549. I took that C value, I plugged it in, I took the 3, I plugged it in, and I got 549. Look what the remainder was when we did this problem. 549. Amazing. That's the remainder theorem. If you take the 0 of the divisor and you plug it in to your dividend, the result will be the remainder. Fascinating. This camera is also fascinating. Can I get just a little more daylight in here? No? What about back here? There we go. Might be too much. I'll double check before I start the next video. Anyway, that's the remainder theorem. Again, if you take the 0 of your divisor and you plug it in, look, here's the x minus 3. If you take that c value of 3 and you plug it into your function, in other words, f of 3, oh, there it is. The remainder is f of 3, or in this case, f of c generally. Use synthetic division and the remainder theorem to find f of 2. Well, synthetic division and the remainder theorem to find f of 2. Well, I could find f of 2 just by plugging 2 into this function, clearly. To use synthetic division to find f of 2, well, let's just start out by finding f of 2. F of 2 equals 2 times 2 to the third power minus 7 times 2 squared plus 7 times 2 minus 6. And that's equal to, this is 16 minus 28 plus 14 minus 6. So we took away we took away 4 7s here. We added 2 7s back. So that's like doing minus 14, and minus 6 makes minus 20. And then we add 6 back, and that should equal 4. Great. So I think the answer is A. Could I do synthetic division also in order to find f of 2? And the answer is yes. How would I do that? This 2 right here that we're plugging into the function is the 0 of the divisor. It's the c value. So that's x minus c appears to equal x minus 2. We could perform synthetic division that would look like this. The 0 of the divisor is 2. That's the number that goes in the little box. And next to it, 2x to the third minus 7x squared plus 7x plus 7x, there it is, minus 6 as a constant value. Skip a line, draw a line, bring the 2 down, and begin. 2 times 2 makes 4, add negative 3. 2 times negative 3 makes negative 6. Get vertical, add positive 1. 2 times 1, 2. Vertically, add, I got negative 4. That's because negative 20 plus 16 equals negative 4. My mistake. So this arithmetic over here did indeed equal negative 4 if I had added correctly. And over here, in synthetic division land, we see that our last number is negative 4. And that last number, whether it's a 0 or it's an actual number, is your remainder. So it's negative 4, which means that, therefore, f of 2 is negative 4. Wow, that's a lot. Thankfully, we still have the factor theorem coming to entertain us. The factor theorem is all about remainders of 0. Because, as I said, 6 divided by 3 was equal to 2. Therefore, 2 and 3 are factors of 6, because you can take the number 6 and factor it. In other words, you can take the number 6 and write it as the product of two numbers. 2 and 3. Therefore, 2 and 3 are factors of 6. And what the factor theorem tells us is that if we took a function, f of x, and we divided it by x minus c. In other words, if we took a function, f of x, and we divided it by x minus c, and we went through the whole process of doing the long division, or even if we did it with synthetic division, and we get a remainder of 0, that means that it divided in evenly. It also means that x minus c is a factor of f of x, because the quotient times the divisor would equal the dividend. The product of those two factors would equal f of x. Which factors? Well, the quotient and x minus c. The quotient times x minus c would equal f of x. What are these two things? They're factors. How do I know? Because they're connected by multiplication. And so they're factors. Yes, they're factors. Factors of what? Factors of f of x. How do you know? Because if you multiply them together, you get f of x. So 2 and 3 are factors of 6? They sure are. How do you know? Because if I multiply those two factors together, I get 6. Okay? This is so closely related to what you learned about long division in 3rd grade that it's painful. The process is more irritating of going through and dealing with all the x's and x to the 5th power and not forgetting to include placeholders when you're missing an x to a power or something. But all in all, the principle at hand here is the same. Quotient times divisor equals dividend. You are very fortunate because that little mark that I put at the bottom of the page tells me that we have reached the end of this section of notes. Ladies and gentlemen, that is Chapter 3, Section 3. It's been a pleasure hanging with you for a while. See you next time.